Nano-syringes, the future of therapeutic drug delivery. Nano-syringes are naturally produced by a type of bacteria that's infectious towards insects, and they're part of the bacteria's infection mechanism. These nano-syringes contain a cocktail of toxins, my favourite of which is called Makes Caterpillars Floppy, shortened to MCF. Now, cast your eyes to the lunar lander. Nano-syringes look very similar to tiny versions of the lunar lander. At the start, I questioned whether nano-syringes are the future of drug delivery. For this to happen, 3 core steps need to take place. First, you need to be able to swap the toxins for some kind of therapeutic drug. Second, you need to be able to produce these nano-syringes at scale. And finally, now this is where my PhD project comes in, you need to be able to tailor the legs of the nanosyringe. So rather than binding and recognizing insect cells, they recognize the cell where the medication is intended. If all of this comes together, we can deliver all therapeutic medication without any side effects whatsoever. The real significance of this can come in the delivery of chemotherapy when fighting cancer. The side effects from chemotherapy can be severe, and in some cases, the side effects alone can be fatal. Additionally, using the same set of steps, nanosyringes can be adapted for the delivery of bespoke fertilizer, increasing the growth of only our intended crop, or it can be adapted to deliver pesticides to a very particular pest, increasing food security in the places that need it the most. It truly is a game-changing technology. Now, I mentioned my project was on tailoring the legs. So how am I going to go about doing this? First, we have to be able to find where on the insect cell do the legs recognize in the first place. To start this, I adapted a system to produce the legs in isolation in both high volumes, high yields, and high purities. Once this was complete, I had to confirm that the legs do in fact bind to our insect cell model. Following this, I smashed up the insect cells and combined all parts of the cell to the nanosyringe legs to see which parts stick and which parts don't. Anything that sticks, this is naturally where the nanosyringe binds. This is where I'm at now. The next steps are to engineer the legs so we can start to bind them to different disease biomarkers. And one day, in the not too distant future, we may be able to treat all diseases with no side effects and increase food security in places that need it the most. Thank you for listening.